Hello everyone, I'm Professor Liu from BA department. Okay, so this week we learned function, and I also want to provide some more advanced knowledge about function. So first of all, I want to share some different function I'm familiar with because I use them in my research. The first one is random function. Okay, so random can randomly select one item from a given range. It's a random function go with choice. Actually, I should say function is a module, and random is a module. In random module, there's a lot of different command or syntax or function you can consider to use. For example, this one, random.choice. Random.choice means random. Okay, after you import random, actually, there are so many different functions in random module. So if you want to know, you can choose random and you click a dot, then click tab. You can see there are so many different some functions you can use. For example, this time I use choice. Okay. If you let me repeat it again. If you want to find all functions, after you write random dot, you can click the tab key, tab key. You can find there are so many different things you can use. Okay, so and this time I want to use choice. Okay, so I use this way, random.choice. Okay, but we back a little bit. In this demonstration, we first build up an element with sunshine, air, water. That are all important elements for lives, right? So if I repeat 3 times, I use for loop to repeat 3 times. Each time, I randomly choose one. Randomly choice 1. Okay, then I can get every time get one element from this list. So sunshine have 1/3 of the opportunity. Air also have the same opportunity. Water the same. So if you repeat multiple times, well, it's rare to see. The 3 elements are the same. Okay, so you can do that. So it's the first one, random.choice. Okay. Second, if in my choice is not a list, instead of it's a string, then the result will show to choose one of the letter from the string. So each of the letter have the same opportunity to be chosen. Okay, so something like that. Okay, so the first one widely used function. Okay, sorry. Is choice. Okay. By the way, you maybe wonder, there are so many different functions in random module. So maybe if you are interested, you can Google it, and maybe you can find the document you want to learn. There are so many different syntax. For example, random choice. Okay, and maybe there are also other. This web page is not good. Let me try to find other things. Okay, this one. Okay, although it's right in Chinese, but actually they provide a lot of good information. So maybe you can find the language you like and to explain how to use random module. Okay, but today I just want to share some of the information I think is very useful in my research. Okay, after random choice, I want to tell you random sample. So for example, I have a list, have the letter from A to K. So in total 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I have 11 letters. And I use the random sample, which means I choose 6 elements from the list. So each of the lists have the same opportunity to become a sample. Okay, so the concept is very similar to non-repeatable drawing. So in some situation, for example, you want to sampling your participant, maybe that's also one good way to help you make the decision. Okay, next one, shuffle. Randomly assign a new sequence. So before shuffle, I have A, B, C, D, E, F, G, H, I, J, K. It follow the standard sequence. But after I use random.shuffle with the element have a new randomly sequence, right? So that's shuffle. It's very helpful when you do some computational simulation. For example, you do poker card, dealing poker card. That's a good way to help you shuffle the cards. Okay, next one, choose a random number from a range. Okay, for example, do you remember in our first 1 or 2 class, we learned the Monte Carlo problem, right? We have 3 doors, and behind the doors have either car or goats, right? So in that situation, we need to make a decision. We want to decide which door go with car, right? We need to choose a number from 1 or 2 or 3. In that situation, we can use random integer. That means we want to choose a number between 1 and 3 and only integer. So that means 1 or 2 or 3. Or similarly, if you want to choose a number from 1 to 100, you can do the same thing. You adjust the start value and the end value, and can help you choose a random integer from a range, right? Okay. If the random number not an integer and actually a number with decimal number, or you want more straightforward, I want to choose a number between 0 and 1, you can use random. In that situation, we can find a value from 0 to 1. And as I know, 0 and 1 are not included. In random integer, they are included, but in random, it's almost never to see 0 and 1. It's almost never to see this number, okay? Okay, let's move on. If you want to use uniform distribution, for example, choose a number from 1 to 100, or maybe I can choose to 0. Uniform distribution, that means each of value have the same chance to be choose. Okay, so that's uniform distribution. Also, sometimes you need normal distribution. Okay, so first you have to use this one, random dot normal variate, and this one is the mu, means the average number. This one is sigma, your standard deviation. So you use these two numbers, you can randomly create a value in a normal distribution, and go with the 100 as the average value and 25 as the standard deviation. So you can adjust your average value, adjust your standard deviation, and use this function to create the sample in normal distribution. Okay, after we learned the sample module, the random module, now we use another demonstration to let you know how to use them. This one I want to demonstrate how to create a slot machine. Do you know what is slot machine? If you don't know, maybe you can first Google it. Slot machine. Okay, this one is a slot machine. And also in Taiwan, there's another type. I don't know if you have similar similar game in your country that I want to show you. In Taiwan, it used to be a very interesting game, a gamble game. Okay, like this one. I don't know if you in your country have similar game. Okay, in Taiwan we call it 小玛丽 because this person is Mario, so it's kind of like a little Mario. So this machine called 小玛丽 or little Mario. Okay, anyway, after you learned random, you can easily create or do the simulation of those games. So first of all, I need to create a spin wheel. You can consider spin wheel is for example in the slot machine. For example, maybe you have 5 outcomes. Each of an outcome can consider the result of a spin wheel, right? Spin wheel. So in spin wheel, maybe we have different outcome, different picture, like cherries, like orange, plum, melon, bell, and bar. Okay, maybe cherry. Okay, so but each of the different outcome actually have different probability. For example, cherry, I want the probability is around 5/20. So in that situation, or you can consider 25%. So if I want this outcome, I can use the random integer. Use this way to help me assign an appropriate opportunity of this outcome. So for example, if n is a random integer from 1 to 20, so the outcome can be as small as 1, as large as 20, but each of the numbers have the same probability to become the outcome. So if n larger than 15, that means include 16, 17, 18, 19, and 20. So totally 5 outcomes out of 20 possible outcomes. That means the 25%, we will return cherry. So similarly, another 25% outcome, it turned out to be orange, and another 25% is become plum. So after that, we have 3 more rare outcomes in the game. Melon. In melon, it's kind of like the number larger than 2 but smaller than 5. In that situation, that includes 3 and 4. 3 and 4 and 5, actually 5. So it's kind of like the probability is 3 out of 20. The outcome will become melon. Then we go to bell. If larger than 1 but smaller than 3, then the outcome only have one. Actually have only 2 value. Oh, sorry, 1 value. Number 2. If number 2, we get bell. If number 1, we get bar. Okay, let me finish. So to help you have a more clear view. Okay, so in total, these 6 outcomes will accumulate as a 100%. Okay, so after I define, or I say I build up this spin wheel function. Every time I want to call this function, I just write the function name, and I can get the outcome. So for example, if I want to build up a slot machine, have 3 outcomes. 3 outcomes. I can use this way. And I can, okay, I should use print. And every time I can get 3 outcomes. If my slot machine have 5 outcomes, I can do that. Okay, but after I build up the spin wheel, and I can reuse it to generate as many outcomes as I want. but I also want to make it more beautiful, right? So for example, after I create the segment, it maybe looks better. If you want, you can also use picture to replace those words. Maybe it's even become more beautiful. But anyway, what I did here is I use the outcome. I create an outcome as a list, and every time, okay, maybe I can skip this one. I explain to you later. And every time I call the function spin wheel to get the return value and append in the outcome list. So after 5 times, and every time I print out, so after 5 times I will get 5 outcome. And I put this one because I want this symbol between each of the outcome. It looks better, more similar to the real slot machine. But you may see in the very beginning, I also need one more of this symbol, maybe this stick. I don't have this one, so I want to print this one first. So overall, after I doing that, I will have 5 outcomes. It's more like a machine. If I don't want 5 outcomes, I can also do 3. Okay, after I simulate the slot machine outcome, I also need to tell my user if the user win the lottery or not. If we keep it simple, we say if any of 2 outcomes are the same content, we say the user win. Okay, so the first part is the same, exactly the same as the outcome. But now I also create if judgment to check if the first outcome or the outcome with index 0 is the same as the second one or third one. In that situation, they are the same, and the user win. Or the second outcome is the same as the third outcome, I also consider user win. Otherwise, the user lose. Okay, so after I write this code, I can also help the computer to do the judgment to check if the user win or not. Of course, you can make it more complicated. Maybe you can consider different figures may have different, if they win in bar because the opportunity is very low. So maybe if the user gets 3 bars, the user is supposed to have more money or better outcome. Something like that you can decide by yourself. But basically, after you know random, you can design a lot of gamble simulation to help you do that type of research. Okay, not only slot machine, poker dealer, also another interesting topics in simulation. So to do poker dealer or poker simulation, first of all, you need to build up the deck, right? A full deck. A full deck will go with 52 cards. And in the cards, we have a full suit, and different numbers. Actually, I should say ranks because J, Q, K, A, they are not numbers. Okay, but anyway, the way I do, I first create full suit and 13 ranks, and I want to combine them. And put in the deck list. So I use a nested loop, 1 control suit, 1 control rank, and I combine them and append into the deck list. So maybe you can check this first. After I follow the sequence to append all the cards, I will get a full deck of poker cards, right? Okay, if I want to shuffle them, do you remember how to do it? Random. dot shuffle and put the deck list. Okay, so after shuffle, you can see I have a random sequence of poker cards. So maybe I can use this to do other simulation. For example, I can give each user certain cards. For example, this one, to see the 30 cards and to see if they get a good outcome or not. But actually, if I use random.sample, okay, if I redo it again, you can see I recreate a new deck. I didn't even do shuffle, but I still can use a random sample to get random cards, 30 random cards to one user. In different game, maybe each user needs different number of cards. For example, 5. Then you can use a random sample to deal the number of cards you want to the user. Okay, it's a very standard way to create a poker card, and to maybe you can follow the sequence and you can create other games. Okay, maybe next time I will create other poker game to do a simulation to help you understand better how to use random to simulate different interesting games. Okay, let's move on. If you remember, if you remember in the beginning of this class, in the very beginning of this semester, we learned Monte Carlo simulation, right? So, and the one drawback when I taught you these topics, it's very hard to use visualize outcome to help you understand what is computational simulation. But now I have the tool. In Python, there is one module called matplotlib. So when I import matplotlib, I import matplotlib.pyplot. It's a very commonly used visualize tool in Python. I import this one because it's too long, so I want a short name. So I import this one as PLT. And in PLT, there are so many different tools. Okay. First, let me show you. After I import this one, I can check PLT. Then please click tab. You can see there are so many things in this module. There are so many things in this module. But maybe we can start with some simple one. For example, today I want to share with you scatter. Scatter used for scatter plot. So in scatter plot, okay. They're very simple. Actually, you can decide the location you want to create the point. For example, I'm in -10 and 10. I want to put a dot here. You can see here one. So the basic input only need two, the x coordinate and y coordinate. So for example, I put 30. It will create in another location. But what if I need more than one? I need more than 1 point. Okay, you can do that. You can create again in other locations. So now I have 2 points. It will automatically assign a color, different color for you. However, if you want to change the point size, you can use these two parameters. S means size, C means color. If you don't want the function to automatically decide the color, you can assign a color. For example, red, R for red, B for blue, and C means color. S means size. Okay. So for example, after I do that, you can see I have a very large red point. I also have a very small blue point. So anyway, That's the standard function you may consider to use when you want to visualize some research outcome. Okay, and remember, it's more like you first create a picture, but after you create, you need to let the computer know when you want to show the outcome. So usually you need to use a plot.show in your code. Okay, let me redo it. The standard way to use matplotlib, actually you need to use the .show to show the result. But I don't know why. Sometimes it will automatically put in outcome. Sometimes you need to use plot.show, then you won't have the outcome. Oh, I know. Sometimes in your code, if you create multiple pictures, you need to let the computer know when to print the outcome. For example, I create 2 pictures. The first one, after I have 2 dots, I show the picture, and then it will clean the picture and start to create the second picture and then show the second picture. So did you get my point? If I put them all together, it just show in one picture. But if you have multiple pictures, you need to let them know when to show the current picture and clean it and then start to do the next picture. Okay, hope you understand the sequence. But however, if I didn't do it, it will consider just one picture and actually put in output, not to print out, okay? So now you know when you need to use plot.show, okay? Just print out, not out, okay? So that matplotlib. Okay, let's move on. After we learn this one, now we can combine with the random module, and then we can to do this research, right? Do you remember in Monte Carlo, when we learn Monte Carlo, we know if there's one randomly generate point in this square, if the point fall in the blue area, there's 4 requirements. The distance between the point to each of the corner point need within the radius of the circle, right? Within the radius. For example, if the radius is 1, for example, this point is 0, 0, 1, 0, 1, 1, and 0, 1. So that means all the circle have a radius as 1 distance unit. So if the distance between the point to this corner point with 1, that means that inside this area, right? Inside this area. So after we repeat 4 times, the second time maybe for this point. So we check if they're within this area. So after you repeat 4 times for each of the corner point, you can see if from point go to each of the corner point all within 1 distance unit, then that means the point is within the blue area. So our purpose is to figure out the size of the blue area, right? Or the percentage. We randomly generate a point, maybe like a raindrop. If the raindrop within this area, what will be the percentage the raindrop into the blue area? Okay, so to do that, we need to combine these 2 modules we just learned. The first one is random, the second one is matplotlib. Okay. And first of all, maybe I need to explain a little bit. In the Matplotlib, there are so many different functions to help you draw a beautiful picture. Okay, first of all, if you want to learn more, you can Google matplotlib.pyplot. You can see there are so many different beautiful picture you can use for your research outcome. Okay, and one thing I want to do is to resize the outcome. For example, if you go back to this one, you can see the distance for x coordinate and the y coordinate are different. If I want to make them with the same size, the same figure size, I need to adjust the parameters. To adjust the parameters, they use this function plot.rc parameters. It's kind of like to adjust your parameters, but this time we want to adjust the parameters of the figure size. So that's a standard syntax to resize the x coordinate and y coordinate. So for example, if the same picture, after I resize to 10 times 10, the x coordinate and the y coordinate will be the same size, right? That's become more beautiful in some situation. Okay, so we back again in this one. First, I resize the output picture, and then this one I want to randomly create 2000 raindrops, and I want to count how many of the raindrops fall into the blue area. So I create a loop, and this loop repeat 2000 times. If you want, you can enlarge the number if you want to find more accurate outcome. And in each iteration, I need to randomly decide the location of the raindrop. So we follow the uniform distribution. For x coordinate, it's a value between 0 and 1. For y coordinate, it's also a number between 0 and 1. So after I have x and y, I know where the drop are going to. And then I calculate the raindrop, the distance between the raindrop to each of the corner points. So A is this point, A is 0, 0. Y is 0, 1, 0, 1. And C is 1, 1, so this point. D is 1, 0, so this point. So after I repeat 4 times, I can check if the distance, A is the distance between the raindrop to the point 0, 0. Okay. Similarly, after I repeat 4 times, I have the 4 distances between the raindrop to 4 corner points. So I check them. If all of them are within the radius 1, then I know it's fall inside the blue area. So what I did here is I use the scatter plot to create a blue point if they fall into the blue area. However, if the raindrop outside this area, I use different color. Purple color. Okay, so after I repeat 2000 times, I can see the outcome. So it's a visualized to this computational simulation. But also I can also calculate the probability of a raindrop fall into this blue area. I use the count because each time it falls into the blue area, I count +1, my count +1. So the total count divided by the total iteration, I know the probability a raindrop fall into this area. That also can help me calculate the blue size area. So if the square area is 1, then the probability of the raindrop fall into the blue area is if 0.2855, that means this area size, blue area size, also 0.2855. But as I know, the number is not that accurate. Maybe I can use a larger number. I can do it again to see if I can get a more accurate outcome. Okay, in the meantime, maybe because my computer is not that fast, I need maybe a few minutes, maybe a few seconds to help me get a more accurate outcome. Okay, this number is more close to the result we get from Excel. But basically, if you use a more larger iteration, you can get a more beautiful picture and a more accurate outcome, accurate number of the blue area size. Okay, similarly, we also can figure it out another problem we already learned in previous class, how to find the pi value. So consider that now we have a square, and each side may be as long as one distance unit. So this point is 0, 0, this point is 1, 1. So similarly, first we reshape our outcome picture. So the size becomes 5 times 5. And in 2000 iterations, we want to check how many times the raindrop fall into the circle area. To fall into the circle area, let me redefine each of the coordination of these 4 points. If we consider the middle point of the circle is 0, 0, then that means from 0, 0 to each of the side is one distance. So then the left bottom corner will become -1 and -1, and this one become 1 minus 1, and this one is 1, 1, and this one is -1 and 1. Okay, so did you get my point? If we consider the middle point of the blue circle is 0, 0, then each of them have different value in coordinate, but the side, the distance of each of the side is 2, okay? So from -1 to -1 to 1, 1, we need to generate the x coordinate and the y coordinate between -1 and 1 to decide the raindrop location. And after we know the raindrop location, we can calculate the distance from the raindrop to the original point. Okay, let me check again how to correctly call the middle point of the circle. Okay, maybe call it origin point of the circle. Okay, I want to know the raindrop, the distance from the raindrop to the origin point of the circle. If the distance is lower than 1, that means it's inside the circle area, right? So I just do this judgment. So actually it's supposed to be the x coordinate -0 and a square. But if x -1 is still x, so I want to skip this part. So as y -0, I just keep y. And also after each of them squared, so x squared plus y squared, I suppose do a square root to find the square root. But think about it, because our compare target is 1, so if both sides, if you square both sides, for example 1 times 1, and this part times square this part, then we can skip the square roots, right? But the right hand side is still 1, so no different. So we can simplify the judgment to become this one: x squared times plus y squared If the sum of these two parts less than 1, that means this raindrop is inside the circle area. If it's inside the circle area, we draw the picture in blue color. But if outside the area, we draw it in black color. Okay, and after repeat 2,000 times, maybe we can estimate the pi value. We can estimate the pi value. Okay, first of all, we found the size of the blue area is, okay, maybe I should not say the size. The probability of a raindrop in the blue area. Actually, it's a probability, not the size. Okay, the probability of a raindrop fall inside the blue area is around 0.77. And because the total size is 2, right? So if a raindrop in the blue area is 0.33, that also means the pi value is around 3.10. I know the number not good, so if I use a larger number, do it again, we suppose can find a value more close to the pi value as we know, right? More close to 3.14 something. So anyway, basically, you can also try it with a large iteration. Okay, the larger the number of the iteration, you can find a more accurate pi value. It's not guaranteed, but supposed to be more close to a correct pi value. Okay, just to share with you to help you understand those computational simulation. If you use Python to do those simulation, you can also draw the picture. Maybe can help you get a better understanding of the computational simulation, or you can call it Monte Carlo simulation. Okay, thanks for your time. If you have any question or any problem, please feel free to discuss with me. I really hope to help you understand those Python programming better. Okay, thanks for your time. See you next time.